Good morning. So today we're going to do the first part of the review for your test, which remember is on the 26th of May. That's next Tuesday at 1 o'clock. So the first part of the review, I just want to go over the equations or formulas that you'll need to know or need to use. So we started out by looking at the formula for slope. Remember, slope is a measure of the steepness and direction of a line. And you can find the slope if you know any 2 points on the line. And the slope is simply y2 minus y1 over x2 minus x1, which we said was the same as rise over run, or the change in y divided by the change in x. Now, depending on how you're given the information to find the slope, sometimes it's easier to just do rise over run. So for instance, for this first question, you can just do rise over run. Okay, you don't have to find the coordinates of these points. We'll do this line x, y, because these points are right on an intersection of grid lines, so it's really easy to find the rise and the run. So to get from x to y, you simply have to go 1, 2, 3, 4, 5 down, and since you're going down, that's going to be a negative 5. And then you have to go 1, 2, 3, 4, 5 across. Since you're going to the right, that's a positive 5. And so your slope, xy, becomes rise over run, negative 5 over positive 5, which can simplify to negative 1. Okay? Again, notice this line slopes down to the right, and it has a negative slope. Okay? We'll just do one more. We'll do hj. Okay? So to get from j to h, you have to go 1, 2, 3, 4 up. Since you're going up, it's positive, and you have to go 1, 2 across. Again, a positive direction, so a positive change. And what that gives you for, here's hj, your rise is 4, your run is 2. That gives you a slope that's positive. Notice you're going up to the right, gives you a positive slope. Another thing I want you to be aware of, you'll notice that JH is much steeper than XY, and you'll also notice that the steeper line has a larger number attached to it for the slope. Okay? So that's finding slope. We looked at a couple of other equations. There's the slope-intercept form. Y equals mx plus b. Remember, that gives you the y-intercept just by looking, and it also gives you the slope, again, just by looking. So if you take any equation of a line and you isolate y, so you get y all alone, then when you look on the other side of the equation, the number attached to x is your slope, and the constant term, the one that doesn't have a variable attached to it, will always be your y-intercept. Okay? Another form that we looked at, ax plus by plus c equals 0. Remember, this is called general form. And general form, you learned in your lesson, I think it was 7.2 or maybe 7.3. You learned that this one is useful if you want to find the intercepts, because if you take your 3 numbers, remember, when in general form, these all have to be integers, and a has to be a positive integer. Okay? But if you rearrange, you can find the y-intercept as negative c over b. Okay? So if you take this number c and divide it by this number b and change it to a negative, you will get the y-intercept. Similarly, to find the x-intercept, it's simply negative c over a. So when you have something in general form, it's really easy to get those 2 points. Okay? So that's where the general form can be very useful. Okay? So we have slope-intercept form, general form, and then the last one that we looked at was just a rearrangement of the slope formula, and that's called the slope point form, where you have y2 minus y1 equals the slope times x2 minus x1. Okay? So, slope point form and slope formula, just a rearrangement, slope-intercept form, and general form. Slope-intercept form is good if you need the slope and the y-intercept. General form is good if you just want to find the x and y intercepts. Okay, so they all have their uses. Moving right along, we talked about this. The steepest slopes will have the largest numbers attached. Okay. Remember, this review has been posted to Google Classroom as well as the key. Okay, so you have all the answers and you have the review. I strongly suggest you work through this review in preparation for your test. Determining slopes, we'll just do one of these because you've had lots of practice with determining slopes. It's simply a matter, if you're given 2 points, it's simply a matter of plugging them into your slope formula and simplifying. So we'll do A. So remember, your slope formula is slope equals y2 minus y1 over x2 minus x1. Again, a reminder that if you don't have your formula sheet, there has been a copy of the formula sheet posted to Google Classroom, and you do need to use that as you work your way through the test on Tuesday. Okay, so we'll plug in our numbers, y2 and y1, 4 minus 0, x2 minus x1, negative 2 minus 2, and that gives us 4 on top. Negative 2 minus 2 is negative 4 on the bottom, giving us a slope of negative 1. Okay? We'll skip number 4. Now, number 5 asks you to do some rearranging. It's vitally important that you're able to rearrange equations, okay? You may be given an equation like this. You need to be able to rearrange that into slope-intercept form, into general form. If you're given an equation in slope-point form, you need to be able to rearrange that into slope-intercept form and general form. Okay, so you gotta get really good at this rearranging business. In this case, it asks you to put it into slope-intercept form, and it reminds you that that's y equals mx plus b. Remember, all these formulas will be on your formula sheet. So if we want slope-intercept form, we simply have to isolate y. That means we're going to have to get rid of this 3x from the left side, and we do that through subtraction. So subtract 3x from this side, it cancels. That leaves you with y equals negative 3x minus 2. Well, it asks you to graph the equation. Before you start graphing, remember, this slope-intercept form gives you the slope. I'm just going to write it as a fraction. Right? That's easy. Just put it over 1. And it gives you the y-intercept. So this line crosses the y-axis at -2. Well, look at that. We have 1 point already. Wasn't that easy? Now, using the slope, which I'm just going to write here, remember the slope tells you how to get from any point on the graph to a second point on the graph. Because our run number, our delta y, is a negative, that means we're going to go down, because down is negative, right? And left is negative. We're going to go down 3. Our change in x is +1, which means we're going to go to the right. So right 1. Okay? So starting at this point, we're going to go down 3, 1, 2, 3. We're going to go right 1. That gives us our second point. And then all we have to do is join those babies up. There's your line. Okay? So remember, your slope gives you directions to get to that second point. Now, question 6 asks you to do the same thing, but it gives you a different form of the equation. It gives you that slope point form, which is almost as easy to use as the slope intercept form, remembering that the slope is right here. The slope is that number that you find in front of the expression containing x. So we know that our slope is -3/1. Okay? The other two numbers, the one attached to the x and the one with the y, are the x and y coordinates of another point on the line. Okay? Now, this is where you have to be very careful. The signs on your numbers will always be the opposite of how they appear in your equation. So, because your y coordinate is -5, you're going to enter it as +5, +5. Because your x coordinate is +2, you're going to enter it as its opposite, -2. Now you have a point and you have the slope, so we're kind of right where we were in the last question. You can plot your point, -2 and 5, so starting at the origin, you go -2 and 5. There's our point at -2 and 5. And then you use the slope. Again, -3 means you're going to go down 3. +1 means you're going to go right 1. Remember, this is the x on the bottom and the y on top. So from here, you have to go down 3, 1, 2, 3, and then you go right 1. That gives you your second point. And again, once you have 2 points, the rest is easy. Join them up. There's your line. Okay? Easy. Find the x and y intercepts of the following equations and graph the equations using the 2 points, the intercepts you found. Now, this one is in general form. So remember, we can use that shortcut where if this is a, right, the one attached to x is a, the one attached to y is b, the constant term, the number by itself, is c, we can say that our y-intercept equals negative c over b, which in this case is negative, now this is a -10, so -10 over b, which in this case is 2. Well, negative is simply +10 over 2. That gives us a y-intercept at 5. So you can plot that. There's our y-intercept at 0 and 5. Okay? Now to find the x-intercept, I'm going to do it the other way you've been taught, okay? And that is, if we want to find the x-intercept, we can substitute 0 for y and then solve for x. This takes a little bit more time, but it might make a little bit more sense. Okay? So we're going to sub in 0 for y, so it'll become 5x plus 2 times 0 minus 10 equals 0. This will disappear, right? 2 times 0 is 0. That gives us 5x minus 10 equals 0. Isolate x, so we're going to add 10 to both sides. That'll give us 5x. This will cancel, equals 10. And then to isolate x, our last step is to divide both sides by 5, giving us x equals 2. See, that takes a whole lot more time, okay? And that's where this nice little shortcut really helps out, okay? Using the shortcut, the x-intercept is simply equal to negative c over a, okay? C again is negative 10, a is 5, and negative 10 is positive 10 over 5, which simplifies to 2. Look at that. Same answer. So whichever of these two ways makes more sense to you is the one you should use. Anyways, we have our x-intercept at 2. That's right there. 2 and 0. And again, as soon as we have 2 points, we're good to go. Join them up. There's your line. All done. Now, for B, since this one isn't in general form, whoops, sorry about that, you've got two choices. You can either put it in general form, right? You would simply subtract 8 from both sides. That would give you 4x plus 2y minus 8 equals 0. And then you can use the shortcut, right? Y-intercept equals negative c over b. Again, this is c, this is b, this is a. So negative c over b would be negative 8 over 2, or positive 4. And our x-intercept would be negative c over a, which would be, there's our c, there's our a, negative 8 over 4, or positive 2. Okay? That's a really quick way to get your intercepts, but if it doesn't make sense to you, you can do it the other way. So, how are we doing for time? So this question says, write the equation of each line in slope-intercept form. Now, they've been kind to us, okay? They've given us the y-intercept. It crosses the y-axis at 0 and negative 2. That means for A, our y-intercept is negative 2. They haven't given us the slope, but you'll notice that there are a number of points where this line goes right through an intersection of grid lines. Here's one of them. Here's another one. So we can just do the whole rise over run thing to find the slope, okay? So slope equals rise over run equals, to get from this point to this point, we have to go 1, 2, 3, 4, 5, 6 up, so that's a positive 6. 1, 2, 3 to the right, so that's a positive 3. So that gives us a slope of 6 over 3, or 2. Once we know the slope and we know the y-intercept, then since they want it in slope-intercept form, we simply plug in our slope where you see m, plug in our y-intercept where you see b, and there you go. There's our equation of a line in slope-intercept form. Easy. Okay? Well, what about this one? Well, this one's a horizontal line, and remember, horizontal and vertical lines can be nasty. Okay? However, take a look at it, go about it the same way. This has a y-intercept. This has a y-intercept at -4. And to find the slope, again, pick this point and any other point on the line. What's our rise here? We don't have to go up or down at all, right? So that means our rise in this case is 0, okay? Because we don't have to go up and we don't have to go down to get from this point to this point. We do, however, have to go 1, 2, 3, 4 to the right. That's a +4, and this, of course, will simplify to 0, which you already knew, right? A horizontal line has a slope of 0. So, when we plug that into y equals mx plus b, since our slope is 0, we plug a 0 in. Our y-intercept is -4, so we go -4. And this disappears, right? 0 times anything is 0. So our simplified equation of this line in slope-intercept form becomes y equals -4, okay? So just remember, if you only have one variable, that indicates that you have either a horizontal line, if the one variable is y, or a vertical line. If we had a vertical line, I don't know, here. This would take the equation x equals 3, okay? Because it crosses the x-axis, so that's why you have the x there, and it crosses it at 3, x equals 3, okay? So, vertical lines are always x equals the x-intercept, horizontal lines are always y equals the y-intercept. So, write the equation in slope-point form. Now, if you want to put it in slope-point form, it tells you right in the name you need to figure out the slope. Whoops. Again, you can't see that. There we go. You need to figure out the slope, and you need the coordinates of any point on the line. Now, they've given us a couple of points here. So, this will be the point that we'll choose to plug into our slope point formula. We could just as easily choose that point, and you'd still be correct. But we're going to pick this point. And this point is -2 and +1. So there's the coordinates for our point. So we've got our point now. It's -2 and +1. And we need to know the slope. So again, because they've been kind to us, well, why don't let's get some practice using the slope formula. So the coordinates of this point are at 3 across and 1 down, so that's 3 and -1. Plug them into your slope formula. M equals y2 minus y1 over x2 minus x1. That becomes y2 minus y1 is -1 minus 1. x2 minus x1 is 3 minus -2. -1 minus 1 is -2. 3 minus -2 is like saying 3 plus 2. That's 5. So there's our slope, -2 over 5. Okay. Now we could just as easily have done rise over run, right? You go 1, 2 down, -2. and 1, 2, 3, 4, 5 across to the right, so that's positive 5. And again, rise, negative 2, run, positive 5. 2 ways to get your slope. Okay? So, now that we have the slope, it goes where you see the m here, and we have a point. That's where you put your y1 and your x1. Our slope point formula becomes, and remember, the signs have to be opposite to what you see here. So, since our y value is 1, we're going to go y minus 1. Our slope is negative 2 over 5. And then x, since our x is negative, we make sure it has the opposite sign, x plus 2. And there's your slope point form. Okay? This will be the last question we'll look at today. We'll do part 2 next day. So this is all the rearranging business, okay? So it says, determine the equation of each line using the slope point form. Then express each equation in slope-intercept and general form. So in other words, put it in one form, rearrange it into the others, okay? And we'll do this one because it's a little bit harder, okay? Because they haven't given us the slope. So if they give you just 2 points, then you got to find the slope first, okay? Not a big deal. So step 1, find your slope. Remember that's y2 minus y1 over x2 minus x1. That becomes y2 minus y1 is 5 minus 3. x2 minus x1 is 0 minus 6. 5 minus 3 is 2. 0 minus 6 is negative 6. And in simplest form, that becomes negative 1 over 3. I just like to put the negative sign up top in fractions. So there's our slope. So to put this in point slope form, again, remember, your slope is, well, let's just write it out. y2 minus y1 equals the slope times x2 minus x1. Your slope goes here. Your x and y coordinates are the second in each case. And I'm going to pick this one because it's got a 0 in it. And that's going to make my life a lot easier. Okay? So, y minus 5, again, notice that the sign changes, equals the slope, negative 1/3 times x minus 0. Right? My x coordinate is 0. And again, that's going to make my life a whole lot easier, right? Because if you add or subtract 0, it means nothing. This will simplify to y minus 5 equals, we distribute, sorry, let me back up. In slope point form, it will look like this, right? So this is our slope point form, okay? Now let's put it into general form. So we're going to simplify the right side. We're going to distribute this negative 1/3 over both of these, and that will give us negative 1/3 x, and negative 1/3 times 0 is just 0. Goodbye, it disappears, okay? Now we want to put this in general form. What does that mean? That means everything on one side, and x, the x coefficient has to be both positive and all integers, okay? So let's move this over here, because that's going to take care of that negative, and it'll also give us everything to one side. So if we want to get rid of negative 1/3 x, we're going to add 1/3 x to both sides. That will give us, on the left side, 1/3 x plus y minus 5. On the right side, these will cancel to give you 0. We're not done yet. We've got to get rid of this denominator of 3. You know how to do that. We just multiply everything through by the denominator we're trying to get rid of. So 3 times 1 over 3 is 3 over 3. That will leave us with simply 1x. 3 times y is 3y. 3 times minus 5 minus 15 equals 0. Okay? So our slope point form is here. Our general form is here. And why don't we just where have we got some room? We'll put it in here. Okay? So I'm just going to rewrite our general form. X plus 3y minus 15 equals 0. Now, we want this in slope-intercept form. So in other words, we want to isolate y. Well, we could either move this 15 and this x over to the right, or we could just move the 3y over to the right. Okay? So I'm just going to move the 3y over to the right. I'm going to subtract 3y from both sides. Goes away from here, and you end up with x minus 15 equals negative 3y. And then my last step, I want to get rid of that negative 3. I want to break it apart from the y. So I'm going to divide everything by negative 3. What does that give me? Well, negative 3 divided by negative 3 is 1. That leaves me with y. Negative 15 divided by negative 3 is positive 5. And x over negative 3 can be more simply written as, not that, negative 1/3 x. Okay. So, slope-intercept form, slope-point form, general form. Okay? That's the end of today's lesson. It's Friday. Have a good weekend. And I will be posting the second half of this on Monday. Have a good weekend.